My name is Zach Thomas, and this is my row reduction project. The problem that I created was Nick is creating a toy car company that will sell 4 models. Model A costs $2 to make, Model B costs $3 to make, Model C costs $4 to make, and Model D costs $2 to make. Nick can only spend $140 on production, and he can only produce 60 cars. Model A sells for $15, Model B sells for $25, Model C sells for $35, and Model D sells for $45, and Nick wants a total revenue of $1,400. How many cars of each model should he sell? So from this word problem, I was able to create 3 equations shown on the right, where x equals the number of Model A cars, y equals the number of Model B cars, z equals the number of Model C cars, and w equals the number of Model D cars. And from these 3 equations, I was able to create the augmented matrix shown on the left, and then I was able to reduce it into reduced row echelon form, which is shown on the right, using the work shown below. The first step was to divide R2 by 2 and R3 by 15, and subtract R1 from R2 and R1 from R3. The next step was to multiply R2 by 2 and R3 by 3 over 2, and subtract R2 from R3. The next step was to divide R3 by 3 and subtract R3 from R1, and the final step was to subtract R2 from R1, which would result in the matrix shown on the right, which is in reduced row echelon form. So from this simplified matrix, I was able to create 3 equations which are shown on the left. These are x minus z equals 30, y plus 2z equals 20, and w equals 10. So from these 3 equations, I was able to set z as the parameter, which I would show as t, and then I was able to create the following parametric equations, which are x equals 30 plus t, y equals 20 minus 2t, z equals t, and w equals 10. And these were created by solving for each of the variables and substituting t for z. The geometric interpretation for the solution is that because there is only 1 free variable and 4 total variables, the solution is a line in R4. The 1 free variable is z, and the 4 total variables are x, y, z, and w. So the only restriction on this problem is that x, y, z, and w must be greater than or equal to 0. This is because you can't sell or produce a negative car. And because x, y, z, and w are greater than or equal to 0, that means that their parametric equations must also be greater than or equal to 0, which is shown on the next step. And from these 4 equations, I was able to show that t must be in between 0 and 10, but it could also be 0 or 10. So because this is the case, I was able to plug in 3 possible solutions, which would be t equals 3, t equals 5, and t equals 7. So when t equals 3, Model A, there would be 33 Model A cars produced, 14 Model B cars produced, 3 Model C cars produced, and 10 Model D cars produced. And this would follow the same instances for t equals 5 and t equals 7, as you can see in the table below. So finally, there were 2 changes that I had to make for my initial matrix. So as you can see in the top right, this is the first matrix that I started out with, and I decided to move away from it because it led to a solution where there were 2 free variables, and I preferred to have my answer with just 1. So then I came up with the matrix shown below, but unfortunately it led to a matrix where w would equal a negative number, which obviously can't be the case because you cannot create or produce a negative toy car. So I simply guessed and checked matrices with different values in row 3, column 5 until w was equal to a positive whole number. And that is the final step of my row reduction project.